So small summary. Okay, so we were discussing about the transportation problem. Okay. Okay, for solving a transportation problem, we have two phases. Okay, that is the first phase, that is finding the initial basic feasible solution. Feasible solution, that is the initial phase. Okay, and we have the second phase, that is finding the optimal solution. Okay, finding the optimal solution. Okay, for finding the initial feasible solution, we have three methods. What were they? Northwest corner method, least cost method, and Vogel's approximation method. Okay, and for finding the optimal solution, which is the second phase, again we had two methods. One, that is MODI method. This method is also called as UV method. Okay, the other one is stepping stone method. Okay, so before doing the three methods in the first phase, we need to ensure that our given transportation problem is balanced. Okay, so the prerequisite is we need to have a balanced transportation problem. Okay, how do you ensure that the problem is balanced? We should have total supply is equal to total demand. Okay, total supply is equal to total demand. If the total supply is not equal to total demand, what do? We have to balance it. Okay, this is called as an unbalanced transportation problem. So we need to balance it. How do we balance it? By adding a dummy column or dummy row. Okay, if the demand is less, okay, if demand is lesser than supply, then we will add a column. If supply is lesser than demand, okay, then what will we do? We will add a row. Okay, and what will be the value of demand in this case? The difference between the supply and the demand. Okay, that value we have to include in the additional dummy column. Okay, similarly in this case, what will be the value that we write in the row? That is the difference of supply and demand. Okay, demand will be higher in the second case, supply is lesser. So we have to introduce a new row, and in that row cost will all be 0, but the supply will be equal to the difference between the demand and the supply. Okay, so by this method we can balance the unbalanced transportation problem. Okay, only after balancing it we have to go for any of the three methods. Okay, for finding the initial feasible solution. Okay, so similarly, before starting the MODI method or the stepping stone method, there is a prerequisite. Okay, the prerequisite is that our problem should be non-degenerate. Okay, our problem should be non-degenerate. How will we ensure that our problem is non-degenerate? We have to check whether the number of allocations is equal to the number of rows plus columns minus 1. Okay, if it is like this, number of allocations that we found in the first step. Okay, in the first step we will get a solution using any of these three methods. We will get a solution. We need to check whether the number of allocations given by any of these three methods is equal to rows plus columns minus 1. Okay, if it is equal, then our answer, the solution is non-degenerate. We can carry on with the MODI method for checking the optimality. Okay, but if it is not equal, if the number of allocations are lesser than the rows plus columns minus 1, then what happens is we need to make this non-degenerate solution into degenerate. We need to make this degenerate. This is the condition for degeneracy. Okay, this is the condition for degeneracy. If it is like this, then we need to convert this problem into a non-degenerate problem. Okay, how will we do that? We'll see it in today's class. Okay, so only once it is non-degenerate, only after making sure that our solution is non-degenerate, only then we can carry out our MODI method, okay, or stepping stone method for checking the optimality. Okay, so is it clear? So these things are the prerequisites that we require. So once again, we have two phases. Phase 1, that is for checking the initial feasible solution. Okay, initial feasible solution. Okay, for that we have three methods: northwest corner method, least cost method, and VAM method, VAM. Okay, among this, VAM is the best method. Okay, and for doing this, we need a prerequisite. Okay, before starting with these three methods, we need to have a prerequisite, that is our transportation problem should be balanced. It is balanced if total supply is equal to total demand. Okay, similarly, second phase, okay, it is for finding the optimal solution. We will be checking the solution that we received from the first phase, is it optimal or not. Okay, for that we have two methods, MODI and stepping stone method. But before starting this, we need to check whether our solution is non-degenerate. Non-degenerate means number of allocations will be equal to rows plus columns minus 1. Okay, if it is lesser, if the allocations are lesser, then we call that problem as a degenerate solution. In that case, we need to convert it into a non-degenerate solution. Only after that, we have to apply these test MODI or stepping stone method for checking the optimality. Okay. Not only that, we in each stage of the MODI method, okay, if there are more than one iteration, in each stage we need to check whether our solution is non-degenerate or not. Okay, in each stage we need to check. Only then we can check for optimality. Okay. So in the second iteration, if you find again it is a degenerate solution, then what you need to do? Again, you need to convert it into non-degenerate solution, and again you need to test for optimality using MODI method. Okay, so with that introduction, we'll go for today's problem, that is degeneracy. Okay, so here we have a problem. Just read the question with me. Please solve the transportation problem whose cost matrix is given below. Okay, obtain basic feasible solution by least cost method. Okay, so in the question itself, they have mentioned that find the initial feasible solution by least cost method and then optimize using the UV method. Okay, UV method is also called as MODI method. Okay, modified solution. Okay, so here this is the question. We have 4 sources that is represented by 1, 2, 3, and 4, and we have 5 destinations A, B, C, D, and E. Okay, so before we start with the any of the methods, for example, over here it is given that initial solution have to be found using the least cost method. Okay, so before starting with least cost method, what should we check? We have to check whether the problem is balanced or not. Okay, so can you tell me if it is balanced? How will you check if it is balanced? We have to add the total demand. Okay, what is the total demand? 20 plus 20 plus 40 plus 10 plus 35. What is the answer? The answer is 125. Okay, so here total demand is 125. Now can you add the total supply? 35 plus 40 plus 20 plus 30. What is the answer? Yes, it is again 125. Okay, so here we have total supply. Yeah, total supply is equal to total demand. So this is a balanced problem. Okay, so in the solution, we'll write the above problem is balanced since total supply is equal to total demand. Okay, hence we find the initial feasible solution using which method? In the question, they have told us to find the initial feasible solution using the least cost method. Okay, so we'll start with the least cost method. Okay, in least cost method, how do we allocate? We allocate using the the cell with the least cost. Okay, I'll just write down the supply. It is 35, 40, 20, and 30. Okay, this is a balanced problem. Here we have 125. Okay, so we are going to start with the cell with the least cost. Which is the cell with the least cost here? Here we have 2, and here also we have, yeah, cell 2. There are 2 cells. Okay, there is a tie. You can select any of the 2 cells. Okay, so I'm selecting the first cell here. Okay, what is the minimum of supply and demand? It is 20 here and 35. So the minimum is 20. So I'll allocate 20. Okay, this will become 0 and this will become 35 minus 20, that is 15. Okay, since this is 0 over here, I will cancel out all the other cells in that particular column. Okay, next, which is the least cost cell? We have the second cell over here with the least cost. So I allocate to this cell. Okay, what is the minimum of supply and demand? Supply is 40, demand is 10, which is a minimum 10. So I will allocate 10 there. I will cancel out and make it the 0, and this one will be 40 minus 10, which is 30. Okay, since it is 0 over here, I will cancel out all the other cells in that column. Next, which is my least cost cell? It is the cell with 3. Yeah. So I will allocate the cell. Over here I have 15 and I have 40. Okay, which is the least value? 15. So this will become 0. And over here it is 40 minus 15. It is 25. Okay. Now since this is 0 over here, I will cancel out all the other cells in that row. Okay. Next, which is my least cost cell? I have 4 here. Okay. There is 5, 15, 20, 15, 14, 13, 4, 15 and 8. So my least cost cell is this one. Okay. Over here, the minimum of 35 and 30. That is 30. So I will allocate 30 here. I will cancel out 30, 0. And 35 minus 30 becomes 5. Okay. Since it is 0 over here, I will cancel out all the other cells in that particular row. Okay. Next, which is my least cost cell? Here I have 15, 20, 14, 13, 15 and 8. Okay, my least cost cell is going to be 8. Okay, so I'll allocate. Over here I have 30 and here I have 5. So I will allocate 5. Okay, 30 minus 5, 25 and 5 will become 0. So I will cancel all the other cells in that particular column. Okay, next I have 15, 20, 14 and 13. So 13 is my least cost cell. I will allocate to that cell. I have 25 and 25 here. It is same. Okay, so I will write 25 here. I will cancel and make this 0. Okay, so I will cancel out all the cells in that particular column. Now this 25 also becomes 0. So I will cancel out all the cells in that row. Okay, next, which cells do I have? Just I have one cell left over here, 15. Now what is my demand? It is 20. What is my supply? It's also 20. Okay, so this problem is a balanced problem. That is why we are having the same demand and supply left over here. Okay, so I will allocate 20 over here. I will cancel and make this 0. I will cut this cell. Then again, I will cancel this 20 also and make it 0. There are no other cells left, so there is no problem. Okay, so this is how we solve this problem for initial solution using the least cost method. Okay, now what we need to find is we need to find the total cost, that is what we get through this method. Okay, total cost is equal to just multiply the allocation. See, the number that we write in the small square is called as allocation. Okay, allocation means from, we have the sources here 1, 2, 3, 4. Okay, 20 here means we can transport 20 units of a product or any material from source 1 to destination B. Okay, what is the meaning of this 2? It costs ₹2 to transport a unit material, okay, from source 1 to B. Okay, for example, there are pencils. Okay, for transporting one pencil from source 1 to destination B, it takes ₹2. Okay, so totally how many pencils we are transporting? We are transporting 20. Okay, so 20 is the number of allocations and 2 is the cost per unit transportation. Okay, for transporting one pencil, it is ₹2. So through this route, how many pencils are we transporting? We are transporting totally 20 pencils. Okay, so totally what is the cost that comes from this route? It is 20 into 2. Okay, so we'll take the total cost here. 20 into 2 plus next one 15 into 3 plus we have 10 into 2 plus 30 into 4 plus 20 into 15 plus 25 into 13 plus 5 into 8. Okay, we will get the total cost as ₹890. Okay, so yeah, 890. So through this method, we are getting a total cost of ₹890. Okay, next we need to go for the optimality condition. Why do we go for optimality condition? We need to check whether this solution is the optimal one. Okay, we told this is just the initial feasible solution that we found through the least cost method. Okay, now we need to check whether this is the minimum cost that we can get. Okay, this is one of the solutions. Okay, if you transport all these allocations, suppose through this route, okay, first source and destination B, if you transport 20 and 20 materials for ₹2, and if you transport 15 materials through source 1 to destination C for ₹3, and similarly all the allocations multiplied by the respective cost, you are getting a cost of ₹890. Okay, we need to check whether this is the minimum cost. Okay, if this is not the minimum cost, then we need to again reduce this value. Okay, that is our objective. Okay, so to check whether this itself is the minimum cost, we have to use the optimality test. Okay, optimality test is achieved through the MODI method, also called as the UV method. Okay, now before doing the optimality method, we told what should we do? We need to check for non-degeneracy. Okay, only if this solution is non-degenerate, then only we can go for the optimality test. Okay, so can you tell me, is this a non-degenerate solution? How do you find out if it is a non-degenerate solution? In a non-degenerate solution, you need to have the number of allocations is equal to rows plus columns minus 1. Okay, so here how many allocations do we have? This is 1 allocation, 2, 3, 4, 5, 6 and 7. 7 allocations. Okay, total number of rows, how many? 1, 2, 3, 4. Total number of columns, 1, 2, 3, 4, 5. Okay, so 5 plus 4 rows minus 1. 5 plus 4 is 9, minus 1 is 8. Okay, so what happens? The total number of allocations is 7, but the total number of rows plus columns minus 1 is 8. Okay, so is it equal? No, it is not equal. So what happens? This solution is a degenerate solution. Okay, so we cannot apply the optimality tests here. So what we need to do is we need to convert this degenerate solution into non-degenerate solution. Okay, so we'll just write the above solution is degenerate as total number of allocations. What was the total number of allocations? It was 7. Okay, and what is rows plus columns minus 1? Rows plus columns minus 1. Rows we had 4 rows. How many columns we have? 5 columns minus 1. That is 4 plus 5 is 9, minus 1 we get 8. Okay, since these two are not equal, we say that our solution is degenerate. Okay, we need to, so what we need to do to check the optimality condition, we need to convert this degenerate solution into non-degenerate solution. Okay, we need to convert the solution into non-degenerate solution so that optimality can be checked. Okay, so what we should do is we have to assign what are the steps for checking non-degeneracy. Okay, I'll show you the steps. See, this is how you can remove degeneracy. Okay, degeneracy means the number of allocations is lesser than m plus n minus 1. Okay, this situation is called as degeneracy. We need to remove the situation. Only then we can apply the MODI method for optimality. Okay, so these are the steps so that you can follow so that you can remove degeneracy. Okay, what are the steps? Allocate a small positive quantity epsilon. Okay, so you are actually using epsilon as your new allocation. okay, which is greater than 0, to a cell based on the following rules. Okay, so to a cell, you have to select a cell from our previous matrix, okay, which does not have any allocations now, and you're going to provide an allocation that is epsilon. Okay, epsilon means a small positive quantity. Okay, now we have some rules so that you can select the cell. Okay, how do you select the cell? We have to select, first of all, we have to select an empty cell. Okay, and this empty cell should have the least cost. Okay, plus what are the other rules? No closed loop should be able to be drawn from this cell. Okay, you start from a least cost cell which is empty. Okay, from that you try to draw a closed loop. You should not be able to draw a closed loop. Okay, is it clear? Such a cell only we can assign this positive allocation epsilon. Okay, if this cell is more than 1, then we can select any cell arbitrarily. Okay, is it clear? So, for removing the degeneracy, why does degeneracy occur? Because number of allocations are lesser. So, what is our aim? To increase the number of allocations. Okay, for that we need to select a cell and we will allocate a small quantity called as epsilon. Okay, now how will you select that cell? We have to select an empty cell having the least cost. Okay, from our matrix. Okay, and this cell, no, from there, if you start drawing a closed loop, you should not be able to form a closed loop. That is the rule. Okay, no closed loop should be possible. And if there are two cells with the least cost, okay, if there are two cells with least cost, okay, following all these conditions, then what can you do? You can select any cell arbitrarily. Okay, so with that, we will go to our problem. So this is our problem. This is a degenerate solution. So we need to convert this into a, which one? We need to convert it into a degenerate solution. Okay, so I'll write assign a small positive allocation epsilon greater than 0 such that the cell has lowest cost and no closed loop is formed. Okay, from that cell. Okay, can you tell me which cell is that? Here, which is the empty cell having the least cost? Can you tell me? From this matrix, which is the empty cell? Okay, which are the occupied cells? Here, this is occupied, this is occupied. Okay, this one is occupied, this is occupied, this is occupied, and this is occupied. Okay, other than these cells, you have to take an empty cell. What are the cells that are empty? Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 12, 13, 14. Okay, all these cells are empty cells. Okay, from this, you need to select a cell with the least cost. Which is the cell having the least cost? Which is the cell having least cost? Yeah, 5. So here we had, this is our previous matrix, okay? Here we had 20 allocations for 50 in this cell, no? I forgot to write it over here. So I'll just write it. 20, okay? So this is also occupied cell. Okay, now other than that, all the other empty cells, which is the least cost, we have a cell with cost 5 here. Similarly, we have a cell with cost 5. This is the minimum cost cell. Okay, for example, I'm going to consider this cell. Okay, I'm going to try to draw a closed loop from this cell. I should not be able to draw the closed loop. Okay, so how will I start? I can draw to in this cell, no? All the corners of the closed loop should be allocated cells. Okay, so if I start from here, I cannot go here because it is already a empty cell. Okay, if I go here, I cannot draw a line. I cannot go here. I cannot go here because all these are empty. Okay, now can I go down? No, again it is empty. Can I go here? Yes, I can go to my left. Okay, can I go to the cell? No, but can I go to the cell over here? I can go. Okay, so I have two routes, either from this cell I can go to this cell, or from this cell, I can go to this one. Okay, suppose I went to this cell. Okay, can I go anywhere else? All the corners of the closed loop should be allocated cells. Okay, so suppose I went from this point. Okay, this point is my least cost cell. Suppose if I took this path here, can I go to any other cells? I cannot go to any other cells. So I'm not taking that path now, but I'm going to take this path. Okay, if I go to this cell, second, which turn can I take? I can go to this cell because this is allocated. Only to allocated cells we should traverse. Okay, so I'm going here. Okay, then I took a right turn here. Okay, and then can I go here? No, because it is an empty cell. Can I go here? No, it is an empty cell. Can I go here? No, it is an empty cell. Here also I cannot go, but I can go to this cell. Okay, so I'm drawing a line straight down. Okay, from here, where can I go? Can I go to this side? No, it is empty. Can I go to this side? No, it is empty. Can I go to 7? Okay, that also I cannot go because it is an empty cell, plus diagonal lines are not allowed. Only vertical and horizontal lines are allowed. Okay, but in my case, I can go to this cell. So I will go here. Okay, next, where can I go? I cannot go to this cell because it is empty. I cannot go to this cell, it is empty. Okay, and diagonal lines are not allowed, so I cannot go to this cell also. Okay, plus it is an empty cell, but I can go from this cell to this cell. Okay, because it is an occupied cell. Okay, only to occupied cells I can traverse. Okay, from here I cannot go here, I cannot go here, but I can go to this cell. Okay, from this cell, can I go anywhere? I cannot go to cell here because it is empty. I cannot go down, it is empty. Okay, I cannot go to this cell, this cell, this cell, it is all empty. Okay, so from this point, I cannot traverse any further. Okay, so what it means is, if I start from here, a closed loop is not possible. Okay, so this is our cell that we are going to assign our epsilon. Okay, so our main objective here was to select a cell such that the cell has least cost plus no closed loop should be possible. Okay, so my least cost, I had two cells here, 5 and 5. I selected this. From this, if I try to draw a closed loop, I am not able to form a closed loop. Okay, so this is this cell satisfies the condition for selecting cell for putting epsilon. Is it clear? Okay. Okay. Just one second. Okay. So here we got the least cost cell. We started from this cell and then we tried for a closed loop, but we could not join a closed loop. So this is the criteria for selecting the cell. Okay, for giving the allocation epsilon. Okay, so this cell over here satisfies both conditions. So this cell I will assign the positive allocation, that is epsilon. Okay, so once this is done, now what we can do is, over here I will update my demand and supply values. Okay, over here it is 20, so I have here 20. Now in this column here it is 20 plus epsilon. So I will write 20 plus epsilon value. Over here it is 15 plus 25, that is 40. Here I have 10, so I have written 10 here. Here I have 30 plus 5. My total demand is 35. Similarly, supply side also you need to update the values. The previous values for supply was 35, 40, 20 and 30. So when we update the supply values, here it is 20 plus 15, it is 35. Here we have 10 plus 30, that is 40. Here we have 20 plus epsilon. So I updated, it is 20 plus epsilon here, and then over here 25 plus 5, that is 30. Okay. So my total value will be 125 plus epsilon. Okay, supply side also 125 plus epsilon. Okay, once this much is done, now check for degeneracy. Now count the number of allocated cells here. We have 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so number of allocations is equal to 8 and total number of rows plus columns minus 1 is also 8. So we have transformed this degenerate solution into a non-degenerate solution. Okay. So now the solution has become a degenerate is non-degenerate, okay? Non-degenerate solution by allocating epsilon greater than 0 to cell. Which cell did we allocate? It is 3B, okay? To 3B. Okay, now what we need to do is we need to apply the MODI method. Okay. Okay. So the solution we have made the solution into a non-degenerate problem, non-degenerate solution. Okay. So next step is we can apply for MODI method. Okay, MODI method we had to do two things, that is find the values of UI and VJ. Okay, and using these values find the opportunity cost. Okay, so we can do that. So we apply MODI method. MODI method is also called as UV method. UV method to check for optimality. Okay, we need to find the values of UI and VJ. Here U corresponds to rows and V correspond to columns. Okay, using the formula, find here the values of UI and VJ using the formula. Okay, what is the formula? Cij is equal to Ui plus Vj. Okay, where Cij is the cost of allocated cells. Okay, now you tell me, if we know the value of Ui, we can calculate the value of Vj, right? How will we calculate Vj? How will you calculate Vj? Ui is equal to, anyways, okay, if you know the value of Vj, you can calculate the value of Ui. How will you calculate it? It will be Cij minus Vj. Okay, similarly, if you know the value of Ui, then you can calculate the value for Vj. Okay, how? Vj is equal to, keep Vj here, take Ui to the other side. Okay, so Cij minus Ui. Okay, is it clear? Okay, so initially we will take Ui is equal to 0. Okay, Ui corresponds to rows. Okay, here how many rows we have? 1, 2, 3, 4. So I have written here U1, U2, U3, U4. Okay, and we have how many columns here? 1, 2, 3, 4, 5. Okay, so corresponding to each column, I have the V values. Okay, V1, V2, V3, V4, and V5. Okay, we need to find the values of each of this UI and VJ. Okay, the same allocations inside that I found in the previous steps, I have written over here. Okay, plus we have our small allocation, which is that epsilon allocation. We gave the epsilon for this 5 over here now. So I'm going to write that epsilon over here. Okay, epsilon over there. Okay, now I'm going to update my demand and supply values. Here it is 20 plus epsilon. Here it is 20 plus epsilon. Okay, yeah. Then I'm going to update my here it becomes 125 plus epsilon. Here also it will be 125 plus epsilon. Okay. Now I'm going to find the values of Ui and Vj. Okay. You can give the values of Ui as 0. For any problem, you can give the value of Ui as 0. But there is a rule. It will be better if you give the value 0 to any of these Uis or Vjs based on the maximum allocation. Okay. In our case, can you tell the rows or column with the maximum allocation? In this row, how many allocations are there? There are 2 allocations. In this row also 2 allocation. In this row also 2 allocation. In this row also 2 allocations. Okay, if you take this column, in this column how many allocation? 1 allocation. In this column 2 allocations. In this column there are 2 allocations. In this column 1 allocation. In this column 2 allocations. So you can take any row or column which has 2 allocations and assign the number 0 to that value. Okay, any one you take and then assign value 0. Okay, or if you don't want to check all this, okay, arbitrarily you can just assign u1 is equal to 0. Okay, you don't have to check for maximum allocations, anything. Just assign for any problem like this. Okay, for starting you can assign u1 is equal to 0. There is no problem. The only thing is your steps, your little arithmetic you will have to do. Okay, that's all the difference, but you will get the same solution. Okay, so in our case, let us assign u1 equal to 0 in this case. Okay, so here u1 equal to 0. Now what we need to find? Since u1 is 0, you know the cost. What is the cost in this cell? It is 2. Okay, don't confuse with this 20. 20 is just the allocation number. Okay, 2 is the cost. Okay, so you need to take the cost outside this smaller square here. Okay, so here you know the cost 2 in the cell and you know the value of u1. Okay, so can you find the value of u2? What will be the value of u2? Sorry, v2 here. Vj is equal to cost minus ui. Okay, so every time you just have to consider this formula. You have to subtract or add the values to the cost. Okay, so cost minus ui. So in this case, what will be the value for v2? We know the cost, that is 2. We know u1 is equal to 0. So what will be v2? v2 will be cost minus this value. Okay, so 2 minus 0, that is 2. Okay, similarly here we have the cost is 3. Okay, u1 value is 0. So we can find the value of v3. So what will be v3? Cost minus the value. Okay, the value that we know. Okay, so here 3 minus 0, that is 3. Okay, next we need to find the other values. Okay, which cell will I take? You need to take a cell so that you know any of the vi or we know any of the vj or ui values and the cost. Okay, so next which cell will I take? I can take this cell. No, here I know the cost as well as the v3 value, so I can find the value of u4. Okay, so what will be u4? Cost minus this value. So it is 13 minus 3, which is 10. Okay, similarly, next, which value can I take? I can take this cell. I know the cost as well as I know the v value, so I can find the u value. What will be the value? 5 minus 2, so u3 will become 3. Okay, next, which cell can I take? Since I know the cost here, the 15 and the u value here, I can find the value of v1. Okay, it will be cost minus 3 here. So that is 15 minus 3, that is 12. Okay, next which cell can I take? Next, which I need to find the value of v4 and u2. See over here, if I take this cell, I need to find v5, u2 and v4. Okay, so which cell can I take again? Can you tell me which cell can I take again? Using this cell, I have got this value and this value. Using this cell, I have got this value as well as that value over here. See? No, you cannot use that also. Yeah. See, using this cell, yeah, you can using this cell, we have the cost as 8. Okay, we know the value of U4, that is 10. So we can find the value of V5. Okay, so cost minus the U value. Okay, so 8 minus 10, that is minus 2. Okay, using this value here, we have the cost 4 and we have the V value. You can find the value of U2. Okay, so here I have 4 minus of this value. Okay, 4 minus, what is the value of V5? It is minus 2. Okay, minus 2. So 4 minus of minus will become plus 2, which is equal to 6. Okay, so U2, I will get it as 6. Okay, next we need to find the value of V4. Okay, here I have the cost 2. I have V2 value as 6. So what will be V4? It is cost. Cost is 2 minus, okay, the value 6. Okay, so that will become minus 4. Okay, so V4 value will become minus 4. Now we have got all the values. Okay, V1 is equal to 12, V2 is equal to 2, V3 3, V4 is minus 4, V5 is minus 2. Again, U1 is equal to 0, that is our assumed value. Okay, this is our assumed value. Assumed value U2 is 6, U3 is 3 and U4 is 10. Okay. Once we find this much, what we need to do is we need to find the opportunity cost. Okay, opportunity cost of the unoccupied cells. Okay, for finding the optimality. Okay, so opportunity cost of unoccupied cells is given by the formula Dij is equal to Cij minus of Ui plus Vj. Okay, this is the formula for finding the opportunity cost. Okay, and this is for unoccupied cells alone. Okay, so how many unoccupied cells are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 unoccupied cells. We need to find the opportunity cost of each of these cells. Okay, the first cell, just write 1, 2, 3, 4, 5. Okay, 4, 5 here so that you can easily identify which cell is this. Okay, so the first cell, it is written as D. The opportunity cost in the first cell will be written as D11. Okay, so I have D11 is equal to, what is the cost there? It is 10. Okay, you need to take only the empty cells, 10 minus of U, which will be the subscript. U corresponds to the first subscript, V corresponds to the second subscript. Okay, so it's U1 plus V1. Okay, which is equal to 10 minus, what is U1 value? U1 is 0. Okay, what is V1 value? It is 12. Okay, 0 plus 12, that is 10 minus 12, which is minus 2. Okay, similarly, find the opportunity cost for all the other remaining empty cells. Second cell, we have D14. D14 will be the opportunity cost in this cell. Okay, D14 is equal to, what is the cost in that cell? It is 15. Minus, what is the U value? Subscript is 1. And for V value, the subscript is 4. Okay, V4, which is equal to 15 minus, what is U1? It is 0 plus what is V4? V4 is minus 4. Okay, so we have 15 minus of minus 4, that is 15 plus 4, that is 19. Okay, next unoccupied cell is, the opportunity cost of the cell is D15. Okay, what's the cost? 9. So D15, the cost over there is 9. Okay, minus U1 plus V, the subscript of V is going to be 5. Okay, now 9 minus, what is U1? It is 0. Plus what is V5 value? It is minus 2. Okay, so 9 minus of minus plus 9 plus 10, that is 19. Okay, next empty cell is in the second row. We have D21. Okay, what is the cost there? It is 5. So 5 minus U2 plus V1. Okay, what is 5 minus, what is the value of U2? It is 6. What is the value of V1? V1, it is 12. Okay, so it is 5 minus 18. Okay, correct, no? Yeah, that is minus 13. Okay, next empty cell, we have the second cell D22. Okay, can you see? The second empty cell is D22. Okay, what's the cost there? It is 10. D22, the cost is 10 minus U2 plus V2, which is equal to 10 minus, what's the value of U2? It is 6. What is the value of V2? It is 2. Okay, so 10 minus 8. Okay, 2. Next one, we have the empty cell D23. Okay, D23, what is the cost there? It is 15. Okay, minus what is U2 plus V3. Okay, 15 minus what is the value of U2? It is 6 plus what is the value of V3? It is 3. Okay, so 15 minus 9, that is, okay, it is 6. Okay, next one, we have empty cell in the third row. Okay, so that is D3 and 3. Okay, D33, that is the cost is 14 minus U3 plus V3. Okay, 14 minus, can you see 14 minus, what is U3? The value is 3. plus what is V3? V3 is also 3. Okay. So that is 14 minus 6, which is 8. Okay. Next one again, D3, 4. What is the cost in that cell? It is 7. 7 minus U3 plus V4, which is equal to 7 minus, what's the value of U3? It is 3. What is the value of V4? It is minus 4. Okay, so 7 minus of, here, can you see? 3 minus 4, that is minus 1. Okay, so 7 minus minus 1. What is the value? 7 minus of minus 1 is 7 plus 1, which is 8. Okay, again, which is the next one? D3, 4, we have already found. D3, 4, we have found. Okay, next is D3, 5, this cell. Okay, so D3, 5. What's the cost there? It is 15. 15 minus, it is U3 plus V5. What is the value of U3? It is 3. 15 minus 3. What is the value of V5? V5 is minus 2. Okay, so that is 15 minus 1, that is 14. Okay, next empty cell, where do we have? In the fourth row. Okay, fourth row, first value. Okay, that is this one. Fourth row, first value, it is D4, 1, and the cost is 20. D4, 1, the cost is 20 minus U4 plus V1. Okay, 20 minus what is U4? It is 10 plus what is V1? That is 12. Okay, 20 minus 22, that is minus 2. Okay, again, next empty cell is D, the opportunity cost is going to be D4, 2. Okay, D4, 2, what is the cost? 15. D4, 2, cost is 15 minus, here, U4 plus V2. What is the value of U4? 15 minus U4 is 10 and V2 is 2. Okay, plus 2. So that is 15 minus 12. Okay, that is 3. Okay, next empty cell we have this one, that is D, the opportunity cost is D4, 4. Okay, what's the cost there? 25. D4, 4. Okay, what is the cost of 25 minus U4 plus V4? Okay, 25 minus what is U4 value? U4 value is 10. V4 value is minus 4. Okay, 10 minus 4, which is 25 minus 6, which is 19. Okay, so now we have all the opportunity cost of all the empty cells, okay, written here. What we need to do is we need to check whether D15, no? 9, okay, sorry. It is, yeah. Over here we have 9 minus of minus 2, that is 9 plus 2, which is, okay, 11. Okay, so now we have the opportunity cost of all the cells. We need to check for optimality. Okay, optimality condition is given by Dij should be either greater than or equal to 0. Okay, so are all our values here greater than or equal to 0? Okay, here we have minus 2, here 19, 11, minus 13, 2, 6, 8, 8, 14, minus 2, 3 and 11. Are all the values positive or equal to 0? No, we have negative values also. Okay, so where do we have negative values? Here minus 2. Okay, here we have minus 13. Okay, then we have here minus 2. Okay, so 3 values we are having negative value. If we have more than one negative value, then always take the most negative value. Most negative value is given by 13, minus 13 over here. The corresponding cell is going to be 2, 1. Okay, 2, 1. That is second row, the first value. Okay, so here we have to start and then we have to draw the closed loop. Okay, so always remember, for assigning the cell for checking the allocation epsilon, okay, we need to check for no loop, okay, no closed loop. Okay, but in this case, this is after checking the opportunity cost, we are going to traverse a path. That should be closed loop. Okay, did you understand? I'll tell once again. For selecting the cell, for assigning the epsilon value, okay, for removing degeneracy, just now we saw. For that, we need to take the least cell, the cell having the least cost, and there should be no closed loop in that case. Okay, I'll just write it over here. Okay, in the case of degeneracy, okay, you need to make the cell as, we need to convert it into a non-degeneracy. In that, we need to take a cell, okay, for assigning the value epsilon as the allocation. Okay, in that case, what will we do? We will take the cell with the least cost and we will go for the cell having no closed loop. Okay, from that cell, we should not be able to draw any closed loop. Okay, but in this case, after checking the optimality, we are now checking the optimality, right? For checking the optimality, we checked whether the opportunity cost. Okay, the opportunity cost, after checking the opportunity cost, we got a cell that is negative. Okay, cell that is negative. From that cell, we have to get a closed loop. Okay, here we should get a closed loop. Okay, in the previous case, we should not get a closed loop. Okay, so for changing the degeneracy problem into non-degeneracy problem, we should check for a cell which is having least cost and no closed loop should be possible. Okay, but in the case of optimality, after applying the Modi method, we are checking for the opportunity cost. In that opportunity cost, we will check for the cell having the negative value. We will take the highest negative value. From that cell, we have to check whether we are able to get a closed loop. Okay, closed loop is required in this case. Okay, so our case, the cell that we are going to take is the highest negative opportunity cost we got in the cell corresponding to 2, 1. Okay, 2, 1 means the second row and the first cell there. Okay, second row, first cell, this one. From this cell, we have to try to draw a closed loop. Okay. So my closed loop is going to be from here. Okay, I'm going to try my closed loop from here. I'm going to draw. I can draw to either this cell or I can draw to this cell, right? If I draw to this cell, okay, then I can join to this cell, this cell, this cell, this cell, and then again this cell, this cell, this cell. Okay, over here closed loop. Then I can come back to this cell. Okay, so now for time being, I'm going to take my closed loop to this cell. Okay, on my corners of the closed loop should be allocated cells. Okay, so I drew this line over here. From here, can I draw to this cell? No, because this is empty. Can I draw to this cell? No, it is empty. Can I draw from this cell to here? No, because that comes as a diagonal line. I cannot use that. Okay, so I can draw to this cell. Okay, so I drew my line to this one. Okay, so my corner of this line is going to be this cell. Okay, next, from here, can I go up? No, because it is empty cell. Can I go down? No, but I can come further down because this is an allocated cell. Okay, all the corners of the loop should be allocated cells. Okay, next I can draw from here to this cell. Okay, then from there, which cell can I go? I cannot go to this one, but I can go to this cell. So I'll draw a straight line to the top cell. From here, I don't have any allocations here, so I cannot take this path, but I can go to the left. Okay. Now again, where can I go? My allocations are there in this cell. So I will come down. Okay. Then where can I go? Here I don't have any allocations. 14, 7 and 15 are the cost. They are not the allocations. I can go only to the left. Okay. From here, where can I go? Where can I go? Can I go to here? No. Can I go up? Yes, because the starting point and ending point should be the same because this is going to be a closed loop. Okay, so from here, even though there is no allocation in this cell, I can go to this because the starting and the ending is going to be the same cell. Okay, so I will go here. Okay, now I have formed the closed loop. Okay, now you need to put the directions. This was my starting cell. 2, 1 was my starting cell. Okay, so here from here I went to this one, no? So I'll put an arrow here. Arrow down, then I went here, then I came up, then I went to the side, then again down, then I went to the side, again down, again up. Okay, so I have put the arrows now. Now what you need to do is, starting from this cell, you need to assign positive and negative signs alternatively. Okay, so the starting cell will always be positive. Okay, so here I have positive sign. Then I went to this cell, no, the last cell. You don't have to consider the cell in between. Okay, that will not be considered. That will be ignored. Okay, in this process. So here plus, next I will put minus. Okay, then I came down, I will put plus. Then I went to the side, I will put minus. Then I went up, I will put plus. Then I went to the side, I will put minus. Then I came down, I will put plus. Then I went to the side, I will put minus. Finally, back to the starting point, I will put plus. Plus is already there, so you don't have to do anything. Okay. Now, what is my next step? I have assigned the positive and negative values starting from the starting point. I have assigned plus, then minus, again plus, all those I have assigned. Okay. Now I have to check all my cells that have a negative value, and we have to take the allocations having the smallest value. Okay. So which cells have negative value here? This is negative value. Okay. So this cell, what is allocation? 20. D24. D24. D24, we will not get any sign because only the corners of this loop only we need to consider. Okay, this one we will not take in this process. Okay, so any allocations that we have in between will be ignored. Okay, only the corners have to be checked. Okay, so corner of this line, we have this line starting point here, ending point here. Only the allocations in between these two we need to check. Okay, this one we don't have to check. Okay, so here check for the cells having the negative value. Here we have one cell, negative value. What is the number of allocations? It is 20. What is the next cell having negative value? This one. It has an allocation 20. Okay, then which is the negative cell? This cell is also negative, having allocation 30. Then this cell is having 25. Okay, so we have values 20, 30 and 25. Which is the smallest value? It is 20. Okay, so this 20 we are going to add and subtract according to the signs. Okay, so this cell, what is the sign here? Negative. Correct, no? In this cell, the sign is negative. So we will subtract 20 from the allocation in that cell. Okay, 20 is my number. Okay, 20 is the number that I have selected for adding or subtracting. I will add and subtract 20. Okay, because when I'm considering the cells having negative value, the least allocation is 20. Okay, is it clear? We had how many cells? 1, 2, 3, 4. 4 cells with negative value. Okay, in these 4 cells, which is the lowest allocation? It is 20. Okay, so 20 I am going to add and subtract according to the sign in that cell. Okay, so here my allocation is 20. 20 minus my number 20. So 20 minus 20, 0. Okay, similarly, in this cell, I don't have any allocations. It was 0. So the sign is plus. So it is 0 plus 20. That will be the new allocation in this cell. Okay, next one. Over here, the sign is minus. No, so 20 minus this 20. Okay, 20 is the number we have selected for adding or subtracting. So 20 minus 20. Similarly, here, the allocation is epsilon, epsilon plus 20. Okay, then in this cell, the sign is negative. So 30 minus 20. In this cell, my sign is positive. So it is 5 plus 20. In this cell, my sign is negative. So it will be 25 minus 20. Okay, so with these values, I'm going to draw the next table. Okay, so I have a table over here. See, all the allocations that does not come in this closed loop, I have to write it just like that in my next step. Okay, in my this step, how many allocations I have not touched? I have not touched this allocation. No, all the other allocations I have already in this the vertices of the closed loop. Okay. Is there any other allocation other than this one? Only this allocation I have not touched. All the other allocations I have already included in my closed loop. Only the vertices, only the corners you need to check. Okay. This 10 to, okay, 10, this cell with allocations 10 and cos 2 has not become a part of the closed loop because 10.2 is not a corner cell. Okay, this is only a part of this line. Okay, it is not a corner cell. Okay, so all the cells which are not part of the corner cells, we'll write just like that into my next step. Okay, so 10.2 I'm writing over here 10.2. Okay, did you see? Okay, now I will write my supply values. Supply, here I have 35, 40, 20 plus epsilon, 30. Okay, similarly the demand values 20, 20 plus epsilon, 40, 10 and 35. Okay, 20, 20 plus epsilon, 40, 10 and 35. Okay, what will you get? It is 125 plus epsilon. Okay, now what will I do? I have made changes in here or no? I am going to subtract 20 from the allocation in this cell. So 20 minus 20. What is the value? 0. Okay, so in this cell, I will not do anything. Okay, next one. This cell, what will I do? The sign is plus. Here we have 15. 15 plus 20, that is 35. Okay, so my new allocation in this cell is going to be 35. Okay. So in this cell, I will write 35. Okay, is it clear? Okay, next one, second row. What happens? Here I have a positive sign. I don't have any allocation. This is the cost. Don't confuse. I don't have any allocations here because in the small square, there is nothing. No, there is nothing in this square. So the allocations is 0. So 0 plus 20. Okay, that is 20. So I will write 20 here. Next one. This is my next cell. Here, sorry, this is my next cell. Here the sign is negative. So 30 minus 20, it is 10. Okay, so here I will mark 10. Next one, third row, here negative sign. So 20 is my already the allocation there. So 20 minus 20. What is the value? 0. So I will not write anything in this cell. Okay, in this cell I will not write anything. Next one. Here we have allocations epsilon. The sign is positive. So it will be epsilon plus 20 allocations in that cell. Okay. So here I have 20 plus epsilon. That is going to be my allocation. Next in this row, there are no more allocations. Here I have 25. The sign is negative. So it will be 25 minus 20. What is that? 5. 5 is going to be the new allocation. Here I have 5. Next one, over here I have 5. The symbol is plus. So 5 plus 20. That is 25. Okay, 25 is my new allocation. Okay, so I have allocated all this. Now what will you check? What will you check for? Once we reach so much, what will you check? We have to check for the optimality. No, this is my new solution. This is my new solution. We need to check for optimality. Okay, using the MODI method. Okay, before checking for optimality, what will you do? You have to check for non-degeneracy. Okay, non-degeneracy, how will you check? Whether the number of allocations is equal to the number of allocations is equal to number of rows plus columns minus 1. Here number of allocations. Can you tell me how many allocations do we have here? 1, 2, 3, 4, 5, 6, 7. Okay. Again, we have the number of allocations is equal to 7. What is rows plus columns minus 1? Rows plus columns minus 1 is equal to, how many rows do we have? 1, 2, 3, 4. 4 rows plus how many columns? 1, 2, 3, 4, 5. 5 columns minus 1. That is 9 minus 1 is 8. Okay, so what can you see over here? Again, the solution has become, solution is degenerate. Okay, solution is degenerate. So what you have to do? You have to make this solution. So convert to a non-degenerate solution. For why are we doing that? For checking the optimality. Okay, so anytime this is a solution that we got from the previous step. Okay, we need to check if this solution is optimal. How will you do that? By using the MODI method. Okay, can you use MODI method in this technique? No, because this is a degenerate problem. So we need to convert this degenerate problem into a non-degenerate problem. Okay, for checking optimality. Okay, so what is the steps for checking for converting a degenerate problem into non-degenerate problem. How do you do that? Okay, how will you convert it? You have to take the cell with the least cost. Okay, empty cell with the least cost. Yeah, and then we have to traverse a loop such that it is not closed. Okay, we should not be able to close the loop. Okay, so can you tell me which is the least cost cell from this one? Least cost empty cell. Which one? Least cost cell? It is the empty cell that is over here, that is 2. Okay, least cost is 2 in all the among all the cells. So I will select this cell. Now I will try to draw a closed loop from this point. Okay, if I am not able to draw a closed loop, then what will I do? I will select this cell itself. Okay, because that is the rule for assigning the epsilon value for this cell. Okay, for removing the degeneracy. Okay, so from here I have an allocated cell here. I cannot move down, I cannot move to the side, I can move only to the cell. Okay, I cannot go to this cell because that is going to be a diagonal line that is not allowed. Okay, only horizontal and vertical lines. So I moved here. Again, I cannot move here because there is no allocations. I can go down, okay, to this one. Now I cannot move this side. I can move only to this side. Okay, then again, I can move up because there is an allocation there. Okay, then to where can I go? I can go to this cell. I can go, but I cannot move up or down. So I will not go here. I will go to this one. From here also, I cannot move up or down. Okay, so we are trapped over here. We cannot go to this cell because that is a diagonal one. So we are not able to form the closed loop in this point. Okay, so this is the condition for selecting this cell as the least cost cell. Okay, for assigning allocation, new allocation, that is epsilon. Okay, did you understand? Our problem is degenerate, so we need to convert this into a non-degenerate problem. For that, we need to select a cell based on the least cost, and one more rule is there. From that cell, a closed loop should not be possible. Okay, so we selected the least cost cell as this cell. Okay, and from here we are not able to draw any closed loop. Okay, so all the criteria has been satisfied. Now I will assign the value epsilon to this cell. Okay, so once I have assigned the value of epsilon, what should I do? I have to correct my total supply and demand values. Okay, over here it will be 35 plus I have assigned an epsilon over here. No, so 35 plus epsilon. Similarly, in this column, it was 20 plus epsilon before. I assigned one epsilon over here extra, so it will become 20 plus epsilon, that is 20 plus 2 epsilon. Okay, is it clear? Now what should I do? Now my solution has become non-degenerate. Can you calculate the number of allocations here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now my allocations are 8. And what is rows plus columns minus 1? How many rows? 1, 2, 3, 4. How many columns? 1, 2, 3, 4, 5. So 4 plus 5 minus 1, that is 8. Okay. So the degeneracy problem has been solved. Okay. Because we introduced one cell over here with epsilon as the allocation. Okay. So now we have a non-degenerate solution. After getting a non-degenerate solution, what should I do? I have to check for optimality. Optimality, how do you check? By taking the opportunity cost. In the opportunity cost, if all the values are greater than or equal to 0, then our solution is optimal. Okay, for checking the optimality solution, we need to get the values of U1, UI and VJ. Okay, how do you get the values? You have the formula. What is the formula that we have? Formula that we have is Cij is equal to Ui plus Bj, where Cij is the cost of occupied cells. Okay, occupied cells. Okay, now I told before I can just arbitrarily take U1 equal to 0. There is no problem. Okay, or you can assign the value 0 to any cell or to any column or row having the most number of allocations. Anything you can do, that is up to you. Okay, so in this case, I'm assigning U1 equal to 0. Okay, now Cij, if I know the value of Cij and Ui, then I can calculate the value of Vj. Okay, similarly, if I know the value of Cij and Vj, then I can calculate the value of Ui. Okay, how will I do that? Cost minus the UI value will give VJ. Similarly, cost minus VJ will give me the value of UI. Only thing you need to remember is you have to subtract the value from cost. Okay, so we'll start assigning the values now. Can you tell me here U1 is equal to 0? Okay, in the cell, I know the cost is 2. I know the value of U1. So I can assign the value of V2. Okay, so here it is 2 minus 0. So V2 will become 2. Next one, in this cell, I have the cost 3. Again, U1 is 0. So it is V3 will be 3 minus 0. So it will be 3. Okay, next, which cell can I use? I have the cost here 5 and I know the value 2. So I can find the value of U3. Okay, so that is 5 minus 2. Okay, so that will be 3. Okay, now again, I know the cost here 13. I know the V3 value. So I can find the value of U4. Okay, 13 minus 3, that is 10. Okay, next, which cell can I use? Okay, over here, which cell is remaining? Okay, I need to find the value of U2. For that, I don't know these two values. Next, I need to find the value V5. Yeah, I can find the value of V5. How? I have the cost here 8 and I have U4 value. So V5 will be 8 minus 10. That is minus 2. Okay, since I know the value of V5, now I know the cost in this cell. So I can find U2. That is 4 minus of minus 2. Okay, how is it? 4 minus of then V5 value. Okay, that is minus 2, which is equal to 4 plus 2, which is 6. Okay, so I assign the value 6 there. Okay, now I need to find the value of V1. Okay, for that I know the cost here 5. 5 minus 6. Okay, that is minus 1. Okay, now I've got all the values. Okay, so here one more value is there, V4. I know the cost here 2. I know U2 value 6. So I can find V4. That is 2 minus 6. That is minus 4. Okay, now we have got all the values. Now what I have to do is I have to calculate the value for the opportunity cost. Okay. Okay. So once I got so much, I will calculate the opportunity cost. Opportunity cost is given by Dij is equal to Cij minus of Ui plus Vj. Okay, in this Cij means that is the cost of unoccupied cell. Okay, that's the cost of unoccupied cell. So how many unoccupied cells do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 unoccupied cells are there. So 12 values we need to find. Okay, the first value here, this is for time being, I'm just writing subscript here. 1, 2, 3, 4, 5. Okay, so first cell is unoccupied now. So I have to find D11. D11 is equal to what's the cost there? It is 10. 10 minus of U1 plus V1. Okay, what is 10 minus? What is my U1 value? U1 is 0. What is V1 value? It is minus 1. Okay, 0 minus 1, which is 10. Minus of minus plus 1, that is value will be 11. Okay, similarly, next one, my next unoccupied cell is D14. D14, what is the cost? Can you see? D14 is empty. Okay, the cost there is 15. So 15 minus U1 plus V4, that is equal to 15 minus my U1 value 0 plus V4 value is minus 4. So that is 15 minus of minus is plus. So 15 plus 4, that is my value is 19. Okay, now again find this one, that is D15. Okay, D15 is equal to the cost there is 9 minus U1 plus V5. That is 9 minus my U1 is 0 plus what is V5 value? It is minus 2. Okay, so that will become 9 plus 2, which is 11. Okay, again D, next value is all, the first row is over, second row D, 2, 3. Can you see? D, this, okay, this cell is empty, so D, 2, 2. Okay, D, 2, 2. What is the value? Cost there is 10 minus U2 plus V2. 10 minus what is U2 value? 6 plus what is V2 value? 2. Okay, 10 minus of 8. Okay, 2. Again, next empty cell is D, 2, 3. The cost is 15. Okay, this cell 15 minus U2 plus V3. Okay, 15 minus what is U2 value? It is 6. Okay, now plus what is V3 value? It is 3. Okay, so 15 minus 9. That is 4, 6. Okay, value is 6. Correct, no? Yeah. Next one, here D. Next value that is empty is D. And this cell is over. Next is D, the third row there. Okay, first cell is empty, so it is D31. That is cost is 15 minus U3 plus V1. Okay, 15 minus what is U3 value? It is 3. Okay, plus what is V1 value? V1 value is minus 1. So 15 minus 2. Okay, 13. Next, my empty cell is over here D33. D33, D33 cost is 14. Okay, U3 plus V3, which is 14 minus what is U3? 3 plus what is V3? V3 is 3. 14 minus 6. Okay, 14 only, no? D33. Yeah. So it becomes 8. Okay. Next, my cell is, yeah, this one. This cell over here, that is empty. Okay, D34. D34, the cost is 7 minus U3 plus V4. That is 7 minus what is U3 value? 3 plus what is V4 value? Minus 4. Okay. So that is 7 minus of minus 1. Okay. 3 minus 4 is minus 1. That is 7 plus 1. That is 8. Okay. So D34. Okay. Next one I have after D3, 4. Next cell is the last cell over here. Okay. So the cost is 15. Okay. D3, 5. The cost is 15 minus U3 plus V5. 15 minus what is U3 value? 3. What is V5 value? V5 is minus 2. So 15 minus of 15 minus 1. That is 14. Okay. Now again, next one, the last row there, D4, 1 is empty. The cost is 20. Okay. Here, D4, 1, the cost is 20 minus U4 plus V1. That is 20 minus what is U4? 10 plus what is V1? Minus 1. Okay. 20 minus 9. That is 11. Okay. Next one, D, second cell here, D42, cost is 15. D42, cost is 15. U4 plus V2. Okay. 15 minus U4 value is, U4 is 10. Okay. And V2 is 2. 10 plus 2, 15 minus 12, which is equal to 3. Again, my empty cell is this one. It is D4, 4. Cost is 25. D4, 4. Cost is 25 minus U4 plus V4. Okay, 25 minus what is V4 value? V4 is 10. What is, sorry, U4 is 10 and V4 is minus 4. 10 minus 4, which is equal to 25 minus 6. Okay, so that is 19. Okay, so we have completed all the opportunity cost. We have checked the opportunity cost of all the unoccupied cells here. Okay, now tell me, is this an optimal or a non-optimal solution? Okay, optimality is if Dij is all greater than or equal to 0, we will get an optimal solution. Okay, in this case, is it all greater than or equal to 0? Here it is 11, 19, 11, 2, 6, 13, 8, 8, 14, 11, 3 and 19. All the values are positive values. Okay, we don't have any negative values. So we can say that this is an optimal solution. Okay. Since all Dij is greater than 0, we have reached the optimality condition. Okay, since we have reached the optimality condition, now what we need to do is we need to calculate the total cost. Okay, total cost is from this. Okay, here total cost we will find from our previous table. Okay, previous table was this one. This table was our just previous table. So from that table we have to calculate the total cost. Okay, so I will calculate the total cost. How will you calculate the total cost? We have to multiply the allocations with the cost. So total cost is equal to here epsilon into 2. Okay, that is 2 epsilon plus here 3 into 35 plus in this row 20 into 5 plus, okay, and this itself is our table, no? Yes. Okay, 20 into 5 plus 2 into 10 plus 4 into 10 plus, here we have 20 plus epsilon into 5. Okay, so that is 20 plus epsilon into 5 means 20 into 5 plus epsilon into 5. Okay, 20 into 5 plus epsilon into 5. Now plus over here I have 5 into 13 plus, okay, 5 into 13 plus 25 into 8. Okay, so this is going to be our total cost. Okay, the cells having epsilon, no, we can just discard them. Okay, because it is only a small positive value, so we can discard the cells having the epsilon value. Okay, so this I will cancel, as well as I have one more epsilon value, no, 5 into epsilon. This also I will cancel. You need to calculate only the others. Okay, so the total cost will be rupees. How much will you get the value? The total cost will be rupees 630. Okay, so this is going to be the optimal solution, 630, and the allocations are going to be all this. Okay, 35 units through source 1 to destination C. Okay, what's the cost? 3. Okay, similarly all the others are our final solution. Okay, so so here we have reached the total cost. The optimal solution is 630. Okay, the cost that we obtained using the least cost method, that was rupees 890. See, this is our initial problem. We solved this problem through the LCM. This is the initial step. Okay, solved through least cost method. The amount was 890. Okay, but after using the optimal method, using MODI, okay, what is our solution? Our cost has been reduced to 630. Okay, and our allocations have also changed. Okay, so this is our optimal solution. Cost has become minimum.